Okay, so the next thing we need to talk about is this concept of molar mass. So what the molar mass is basically the atomic mass of an element or compound given in grams that contains an Avogadro's number of particles. So basically the molar mass is the mass for every 1 mole of a compound. In your book they're usually expressed to 4 significant figures. So let's talk about how to determine this molar mass. Luckily for us, you can just write down the chemical formula of the compound and then look up the values for the molar masses straight from the periodic table. So the way to do this is to convert the atomic mass units on the periodic table to grams and then sum the masses of the total atoms present. So they have an example written for you here. So if you have calcium fluoride, so it's CaF2, and you want to get its molar mass, you need to look at your periodic table and find the weight of calcium, which if you read off your periodic table, it's 40.08 grams for every 1 mole. And then you need to recognize that there are 2 fluorines. So the atomic mass of fluorine is 19 grams, and you multiply that by 2 because there are 2 of them. And then you just sum this together to get the molar mass, which ends up being 78.08 grams. So I just want to remind you once again that moles of different elements are going to end up having different weights. So here in this figure there's a mole of different elements. So here's sulfur, iodine, iron, and mercury. They all are containing Avogadro's number of atoms, so this is 1 mole of each substance, but you can see they have different weights. And once again, this is something you can read off the periodic table. So the iodine is heavier than the sulfur because we're just counting the same number of atoms, so they end up having different weights. So just like the dozen eggs and the dozen donuts have different weights, a mole of each one of these compounds ends up weighing something different. So the other thing we need to use is the fact that we can use these molar masses as a conversion factor when we solve problems. So here's an example. So this question's asking how many moles of lead does 15 grams of lead represent. So you have the number of grams of lead and you know the molar mass of lead that you can read off from the periodic table, and you can use this to convert that value of mass into moles. So from the periodic table you can figure out that a mole of lead weighs 107.2 grams, and you can use that to construct a conversion factor, just like we've been doing in the other previous lectures. And then you can use this to calculate. So once again, they want to know how many moles are in 15 grams. So we start with our 15 grams of lead, and we multiply by our conversion factor. So there's 207.2 grams in every 1 mole, and it works out to be this 7.24 times 10 to the minus 2 moles. So you can see it's much less than 1. The reason being 1 mole is 207, so 15 grams is just going to be a fraction of the mole. So let's look at another problem. So how many moles of mercury are there in 23 grams of mercury? So you can try to solve this one on your own, and I will give you the solution in the next video.